Rates 2018. Let's have a look at this one then. So question 5. What we've got here, we've got a full set of data for experiment 1, we've got a rate equation. So it's asking you to plug the numbers in for experiment number 1. You've got a rate 0.024, you've got no K, you've got values for everything else, the BR03 minus, you've got as 0.1, you've got the BR minus as 0.2, and in the rate equation you need H plus squared, so that's 0.3 squared. Rearrange it, and you've got K 13.3. All of my data is to two significant figures, so I'm going to put it to 13. I've now got the rate constant K. I'm hoping that somewhere it says that the temperature isn't changing. Yes, at a given temperature in the question. So all the experiments, the rate constant hasn't changed, remember. There's only temperature that will change the value of the rate constant. So we've got K for everyone. And you just plug them in. So I've got rate equals K multiplied by the concentration BrO3 minus, multiplied by the concentration Br minus, multiplied by the concentration H plus squared. And I'm just plugging numbers in and using K at 13 and working out various different parts of it. And yeah, that's fairly straightforward. Work out the units of K. Well, I've got rate is in mole divided by decimeter cubed with a second on the bottom as well, so it's divided by second, multiplied by K, and then in the rate equation I've got one concentration, BrO3 minus, one concentration, Br minus, two concentrations because it's H plus squared, so I've got 4 concentrations. So I've got mole divided by decimeter cubed times mole divided by decimeter cubed multiplied by mole divided by decimeter cubed multiplied by mole divided by decimeter cubed 4 times. Cancel a mole on each side, cancel a divide by dn3 on the bottom on each side. So you've got second on the bottom on the left now, K, and I've got 3 mole divided by decimeter cubed. Take the 3 decimeter cubed from the bottom on the right hand side up to the top on the left. Take the 3 moles down to the bottom on the left, from on the top on the right, down to the bottom on the left. And I've got dm3 times dm3 times dm3, which is dm to the 9. I've got a mole and a mole and a mole on the bottom, and I've got a second still on the bottom. Take it up into standard form. Mole 3 on the bottom becomes mole to the minus 3. Second to the 1 on the bottom becomes second to the minus 1. So I've got dm9. Mole to the minus 3, second to the minus 1, in any order you wish. Right, I've got an Arrhenius equation here. Is it asking me to plot a graph? Yes, it is, because there's a piece of graph paper. What's it asking me to plot? It's asking me to plot ln 1 over t and 1 over t on the right hand side. And it gives me this equation here, so you've just got to kind of look at it and not be frightened of Arrhenius equation. Y equals mx plus c. So, y, ln 1 over t, yes, you've got ln 1 over t at the y, equals minus ea over r, that's the gradient, as long as 1 over t is the x, minus ea over r is the gradient if 1 over t is the x, and it is add a constant, okay? The constant is the intercept on the y-axis. But that kind of doesn't matter. We know that the gradient of the line is minus ea over r, and we're being asked to work out ea. So you work out the gradient, which is the change in y. Make sure you cross the axes and then work out before and after. So yeah, or maybe take 2 neat points on the graph, and I've worked it out. My gradient to be minus 6640, and that equals minus ea over r from the general equation for a straight line, y equals mx plus c. Why is it negative? Because the graph's going down from top left down to bottom right. So it's a negative gradient. Reverse both sides. EA over R is 6640. That's the gradient. R is 8.31, so EA divided by 8.31 is 6640. Multiply both sides by 8.31. EA is 55178, and it's in joules per mole. That's what EA is in. It wants it in, I don't know it's in joules per mole. I know it's in joules per mole because I can see joules in the R. It says joules in R, so it's going to be joules per mole. And yet on the question, I think it asks for kilojoules per mole. So joules small up into kilojoules divided by 1055.2. I've put it to 3 significant figures because all of my data is to 3 significant figures.